In this video, you will learn how to solve the area of a regular pentagon circumscribed about a circle given the area of a circle. A regular pentagon is circumscribed about a circle. The circle has an area of 153.9. Find the area of the pentagon. So it's stated here that a regular pentagon is circumscribed about a circle. So let's draw that first. Okay, let's say this is our pentagon. Right. Okay. And then it says it is circumscribed about a circle. So the circle should be inside the pentagon. So it should look like this. And parts of the circle touch the sides of the pentagon. So that one. Alright. And it's also stated here that the area of the circle is equal to 153.9. And then we solve for the area of the pentagon. Now to solve for the area of pentagon, that would just be the perimeter of the pentagon times the apothem A over 2. So the perimeter would be the sum of the sides of the pentagon. And then the apothem would be this one. The line from the center of the pentagon at right angles to any of its sides. So the apothem should be this one, or here, or here. Let's say just this one. All right. So this is the apothem of the pentagon, and this is also the radius of the circle. Therefore, the radius of the circle in this case is equal to the apothem of the pentagon. And now we can start solving. Since we're given here the area of the circle, right, and then we can solve for its radius. The area of the circle can be calculated using the formula pi r squared, where r is the radius and pi is equivalent to 3.14. So we just plug in the value of the area, which is 153. So 153.9 equals pi r squared. Then we divide both sides by pi. Okay, to get rid of the pi here. Then r squared is just equal to 153.9 over pi. Then we can solve for the radius by getting the square root of both sides. Okay. And then this would become r squared of r squared is r equals the square root of 153.9 over pi, which is just equal to the square root of 48.99. Therefore, r is approximately equal to 6.99 or 6. This is equal to 6.99, which we can round off to approximately 7. So that is the radius of the circle, which is also equivalent to the apothem of the pentagon. Now we already have the radius or the apothem of the pentagon, but we don't know the perimeter. So the perimeter should be, to solve for the perimeter of the pentagon, we should know um, the length of each of the sides of the pentagon. Now, since a pentagon is a 5-sided polygon, then we can solve for the angle. Let me just delete this. Okay, so we can solve for this angle here, or maybe this one. We can solve for this angle. Let's say this is theta. All right. So theta here is just equal to 360 degrees divided by n, where n is the number of sides of a polygon. In this case, we have 5 sides because this is a pentagon. So 360 degrees divided by 5, and theta is just equal to 72 degrees. Therefore, each of the angles here is equal to 72 degrees. Therefore, this angle here is half of this angle. So this one is 36 degrees. And by the way, if we connect all the vertices of this one, the pentagon, to the center, we will create or form 5 triangles. And each of these triangles have equal angles, which is 72 degrees, and half of that is equal to 36 degrees. And now we have this triangle here, which is a right triangle. So let me draw that here so it would be clear. Let's project that here. So this angle here, this one, this triangle here is this one. All right. Okay. So this is 36 degrees. And this is the radius or apothem, which is 7. But we don't know this one. Okay. This one is half of the side of the pentagon. Let's say this is y. So we let this side as y. Okay. Now to solve y, we can use the trigonometric function tangent. So we get the tangent of theta. Tangent theta equals opposite over adjacent. So the opposite side of angle theta, which is equal to 36, is y. So that is y over the apothem, which is 7. So this would become tangent 36 degrees equals y over 7. Therefore, y is equal to 7 times tangent 36 degrees. All right, so let me delete this. Okay. So y is just equal to 5.09. Alright, is that 5.09 tangent 36 times 7? Yeah, 5.085, and we can round it off to 5.09. Now we already have the value of y, half of the side of the pentagon. Therefore, the side is just equal to twice of that. So that is times 2. Therefore, the side of each of the sides of the pentagon is equal to 10.18. Then we get the perimeter. Perimeter is just 5 times the sides. So this is 5 times 10.18, which is just equal to 50.9. And now we can solve for the area of the pentagon. So let me delete this. So area of the pentagon is just equal to the perimeter, which is 50.9, times the apothem, which is 7, divided by 2. And this is just equal to 178.15. And there's another way to solve this. We can get, okay, let me show you. We can get the area of the triangle. Here, the area of this triangle. Then we multiply by 10, because there are 10 triangles here. We cut this into half. Yeah, 10 right triangles. So let's try that. So area of the triangle, the right triangle, is 1/2 base times height. Let me change this. So the base is y, this one, which is 5.09, and the height is the radius, which is 7, or the apothem, and this is just equal to 17.8. And now the area of the pentagon is just the area of the triangle times 10. So this is 17.8 times 10. Still we get 178 for the area of the pentagon. Yeah. We didn't get the exact value here because I rounded off. So you should not round off before you get the final answer.